Hello and welcome you all to the quick solutions of All India AIATS Test Series Medical 2019. Test number 11, code A and B, dated 7th of April 2019, and I am here to discuss the physics portion. So let us get started. So here is question number 1, everyone. A quantity y is given by y equals epsilon naught L dV by dt, where epsilon naught is permittivity of free space, L is length, dV is small potential difference, and dt is small time interval. The dimensional formula for y is same as that of what? Means we have to calculate the dimensional formula for y. Expression is given y equals epsilon naught L dV upon dt. Now we can write the dimension of y as dimension of epsilon naught, dimension of L, dimension of potential divided by dimension of time. Now we know very well that potential V equals 1 by 4 pi epsilon naught R Q. It means the dimension of V will be dimension of Q divided by dimension of epsilon naught, dimension of R, that is simply L. So let's put it. We will get epsilon naught dimension, L dimension, dimension of V is Q upon epsilon naught L, and T is already there. So epsilon naught cancel, L cancel, dimension of charge upon dimension of time, that will give you the dimension of electric current. So here you will get the dimension of electric current simply. So that's why we will go with option number 3, which is absolutely correct. Now let us move on to the next, that is question number 2. So here is question number 2, everyone. Two particles of masses 2 kg and 4 kg are placed x-axis at position x equals 1 meter and x equals 4 meter respectively. The moment of inertia of the system about an axis passing through center of mass and parallel to y-axis will be what? Now, in order to calculate the moment of inertia, first of all we have to calculate where the center of mass of these two objects lie. This is the coordinate axis. Suppose we are having y-axis, x-axis, origin. Particles are at x equal to 1 and x equal to 4. 2 kg right here, 4 kg right here. Now we can write the coordinate of center of mass, that is only x center of mass will be here. XCM given by m1 x1, that is 2 into 1 plus m2 x2, 4 into 4 divided by total mass, that is 6. After solving we will get 3 meter or 3 as x coordinate of center of mass. It means center of mass will lie at a distance 3 from origin, so that is somewhere right here. So we have to calculate the center of mass about this axis, and this is x equal to 3, means the distance from 2 kg object is 2 meter, and from 4 kg object it is just 1 meter. Now we can calculate the moment of inertia very simply. I about C equals m1 r1 square plus m2 r2 square. m1 is 2, r1 is 2 square plus m2 is 4 and r2 is simply 1, so 1 square. After solving we'll get 12 kg meter square as moment of inertia of this system about its center of mass. So we can say that option number 2 is absolutely correct, so we will go with option number 2 only. Now move on to the next, that is question number 3. Here is question number 3, everyone. A percentage error in measurement of mass and speed are 1% and 2.5% respectively. The maximum percentage error in the calculation of linear momentum will be what? The question is basically from error. We know very well that the linear momentum P is given by mv. Now, we must be knowing that the relative error in P then will be given by relative error in m plus relative error in v, where m is mass, v is speed. Now, if we multiply by 100 both sides, then we will get the respective percentage errors. So, therefore, percentage error in P will be equal to percentage error in mass plus percentage error in speed. Already given 1 plus 2.5, that is 3.5% will be the percentage error in momentum. Option number 1 is absolutely correct. So, option number 1. Move on to the next, that is question number 4. So, here is question number 4, everyone. Velocity time graph of a particle moving along straight line is shown in figure. The displacement of the particle from t equal to 0 to t equal to 4 seconds will be what? Now the question is based on motion under graph, where we have to calculate the total displacement covered by the particle from 0 to 4 seconds from the given Vt graph. We know very well that the area of Vt curve gives displacement. So, since area of velocity time graph gives displacement, so we have to calculate the displacement covered from 0 to 4 second interval. So, we have to calculate that much area only. So, here displacement will be this triangle area plus this rectangle area plus again this triangle area. So, we will get for triangle 2 into 10 divided by 2 plus 1 into 10 plus 1 into 10 divided by 2. And after solving, we will get 25 meter as displacement. It means we have to go with option number 3, which is absolutely correct. So, therefore, option number 3, everyone. Now, move on to the next, that is question number 5. Here is 5th question, everyone. A particle of unit mass is moving along x-axis. The velocity of particle varies with position x as Vx equals alpha x to the power minus beta, where alpha and beta are positive constant and x is greater than 0. The acceleration of particle as a function of x will be what? Now we have to calculate the relation between acceleration and the respective position. We can calculate it. We know very well that A equals v dv by dx. So we can get the acceleration from Vx relation here. So v is alpha x to the power minus beta. Now A, that is v dv by dx, further can be written v alpha x to the power minus beta. Now we have to differentiate this v, that is alpha x to the power minus beta, with respect to x. Let's do it. Alpha x minus beta, alpha comes out of the differential operator, minus beta x to the power minus beta minus 1. Now therefore we will get alpha into alpha, that is alpha square, minus sign into beta multiplied by x to the power minus beta, that is minus 2 beta minus 1. So this is the relation between acceleration and position x. So therefore we can say that option number 2 is perfectly matching with our final result. So option number 2 is absolutely correct. Therefore second option. Now move on to the next, that is question number 6.